Hello students, welcome to the video of 7th General Science. Our today's topic is sound, production of sound. We hear different types of sound around us. Some may be harsh or some may be pleasant. So the question is, how does sound produce? We already discussed about it in the 6th class. So let's see how does the sound produce. When we struck any object or when we pluck any object, then the vibration are produced in an object, and when the vibrations are produced, then the sound is produced. Means vibrations are very essential for the production of sound. Without vibrations there is no sound. Now let's see about the oscillator, oscillations and oscillatory motion. When object moves in a to and fro motion, then that object is called the oscillator. Means the motion of the oscillator or the movement of the oscillator is in a fixed path to and fro, that is called the oscillator. And when object moves from its original position to another position and again come back to the original position, then that motion is called or then that rotation we can call it the oscillation. Now the motion is called the oscillatory motion. Now let's see about the time period of the oscillation and the frequency. The time required by an oscillator to complete one oscillation. Now we know the oscillation, when the movement of the oscillator starts from starting point and reaches to the another point and then it comes back to the original position. That motion or that moment rotation we called it the one oscillation. Now you can see the in picture the ball or the ball of the pendulum. The starting position of the ball is C. Then if we drop it from C, then it reaches to A, then to B, from B to A, and again from A to C. This complete path is called the one oscillation. Now the number of oscillations completed by an oscillator in a 1 second is called the frequency of the oscillations. Means if object rotate 100 times in a 1 second, then the frequency of that object is 100. That is called the frequency of the oscillation, that oscillations complete in 1 second. And we can find the frequency of any object by using the formula 1 upon time period of oscillations. Means how much time required to complete the oscillation, and it is denoted by letter n. N is equal to 1 upon t, and the unit of frequency is hertz, and it is denoted by the letter capital H and small z as z, hertz. Now let's see about the high pitch and low pitch. Take a wooden board, hammer 2 nails into it, each few centimeters away from two ends. To tie the ends of the thin metal wire to the nails so that the wire is stretched tightly between them. Insert a wedge-shaped wooden or plastic block under the wire near each nail and plug the wire lightly. You will hear the sound. Now put some rectangular blocks under the wedge, any one of the edge. Now you will observe that the wire become more stretched. Their tension increases in the wire. Now again plug the wire. What do you observe? The sound when the tension was low in the wire, the sound become dull. But if we increase the tension in the wire, then the sound shrills. You can also perform this experiment in other way. Take a rubber band and put it in your 2 fingers and vibrate it. You will hear some sound. Now take your fingers away from each other. There will be a tension in the rubber band, and now again vibrate the rubber with the same force. You will hear the more sound, strong sound, shrill sound. That is the high pitch and low pitch sound. When the tension in the rubber band was low, the sound was dull, but if we increase it, the sound become shrill. So this is the pitch of the sound. When the tension is increased, the resulting sound is shriller, and when the tension is reduced, the sound also less shrill, or we can call it a dull sound. This is what is called the low pitch sound and high pitch sound. If the sound is shrill, then we called it the high pitch sound, and if the shrill is less, then we called it the low pitch sound. Next point is the intensity of sound and sound level. So some sounds are loud or some sounds are soft. So loudness or softness of sound is indicated by two terms. First is intensity of the sound and second is the sound level. Sound level is the intensity of sound as perceived by our ear. Means how much sound is understood by our ears is the sound level. The intensity of sound is proportional to the square of the amplitude of the vibration. We know that amplitude is the maximum distance on the both sides from mean position. Intensity is proportional to the square of the amplitude of the vibration. Means we double the amplitude, then the intensity of sound become 4 times more. Next is the audible sound. The sound which can be heard by the humans, that sound is called the audible sound. The sound between 20 Hz to 20,000 Hz can be heard by the humans. Means if the object producing 20 vibrations in 1 second or 20,000 vibrations in 1 second, that sound is heard by the humans. So the range of the sound between 20 Hz to 20,000 Hz is heard by the humans. That's why it is called the audible sound. Next is the infrasonic sound. So if the range of the sound is between 1 Hz to 19 Hz, that sound is called the infrasonic sound. Means the frequency of such sound is so low that humans cannot hear it. So this sound is called the infrasonic sound. And the examples are falling of the leaves or movements of our hand has the very low frequency. That's why it is not audible. Next is ultrasonic sound. Did you see that the bat is flying at the night? It produces the sound when it flies. Can you hear the sound? You cannot, because the frequency of that sound is above 20,000 Hz. And as I told you, the human ears can hear sound up to 20,000 Hz only, but it produces the sound higher than 20,000 Hz. That's why it is not audible. The frequency of ultrasonic sound is above 20,000 Hz and it cannot be heard by the humans.